Thank you for allowing me to present today. My name is Julie Gambill, and again, I'm located in Ashland, Kentucky. I've recently completed the data analysis pathway with CodeU. After
Nice.
17 years in retail management, my most recent position was eliminated in March of last year, leading to the need to change careers. I've always had an interest in problem solving and storytelling, and data analysis is a great way to do just that. I did my project on wastewater dumping and seismic activity with a focus on the Appalachian Basin region and the Oklahoma region. In this project, I analyzed the relationship between wastewater dumping and seismic events in the Oklahoma region. I also compared the seismic events in Oklahoma to the seismic events in the Appalachian Basin region. In recent years, both the Appalachian Basin and Oklahoma regions have experienced significant increases in seismic activity. A growing body of research suggests that the rise may be linked to wastewater injection, a common byproduct of hydraulic fracturing or fracking. This may increase the magnitude and depth of seismic events. Understanding this relationship is critical for assessing environmental risks and developing strategies to minimize human-induced seismic events. To get started on this project, I utilized 3 datasets: the earthquake CSV from the Appalachian Basin Play Fairway Analysis, Gravity, Magnetics, and Earthquake data located on data.gov. This dataset featured over 1,600 rows and 12 columns. The OK Quake CSV and Injection Wells CSV from Oklahoma earthquakes and saltwater injection wells located on Kaggle.com. The OK Quake CSV featured over 13,900 rows and 22 columns. The injection well CSV featured over 11,100 rows and 21 columns. To use these datasets properly, I relied on specific programs for data analysis and visualization. I used Jupyter Notebooks with Python, Pandas, and NumPy for data cleaning and analysis, and I used SQLite 3 for my database and queries. I used Matplotlib to help visualize the data, like this graph on the right, showing the majority of seismic events in 2013 occurred in West Virginia. I also utilized Seaborn, Plotly, and Plotly Express and GeoPandas to showcase meaningful and accurate visualizations. But first, I needed to make sure the data was ready for analysis. I arranged each dataset into its own Jupyter notebook for easier organization. I then went through each dataset individually and prepared the data for analysis by renaming columns to a common name amongst the 2 earthquake datasets for easier merging of SQL tables. For example, in the top image, unnecessary capital letters and underscores were removed. I dropped columns that were not going to be used for this analysis and/or had too much missing information, as seen in the bottom image. The remaining null values were identified and removed or replaced. I created a function to split the date-time column, correct the data type to datetime, and the function also adds month and year columns and moves all the new date columns to the front of the column list for easy access. I also needed to reformat the locations from a description to a specific state location. This was one of my biggest challenges because I needed to reformat over 15,500 values. I utilized ChatGPT to assist in prepping the values for reformatting by adding quotations and commas after the values so that I could easily and quickly add them to a list. The bottom right graphic is an example of the descriptive locations that were reformatted to just the state locations. After cleaning the data, I began some visualizations and set up my SQL database. To set up my database, I created an ER diagram for my tables. Because of the way the data was listed, I needed to make 2 separate diagrams. I organized the columns from the Oklahoma and Appalachian region earthquake datasets into one section, and the injection well columns into a separate section. I ran the tables separately with SQL queries. However, they could be joined on latitude and longitude if necessary. Instead, I used GeoPandas to overlap visualizations from the separate queries. First, looking at the state of Oklahoma data, I used a SQL query to pull the injection well approvals from 2000 to 2016 and grouped by year to see the change in well approvals, which resulted in an increase. For the diagram, I used the result of the query of injection wells, where I joined 2 tables on a primary key to have well locations and well order information. I also specified between 2010 and 2016 to show the locations of approved wells during that time period. Using GeoPandas, I created an interactive map on the injection well sites in the state of Oklahoma. You can zoom in or out and hover over blue point for the specific well ID, not shown here. I used the same process as before to compare the locations of the injection well sites to the seismic event locations for the same time period between 2010 and 2016. First, a SQL query of the event locations joined with event dates, then utilizing GeoPandas to produce the interactive map of seismic events. Hovering over one of the red points would show the specific event ID. This process showed me that there were more seismic events and injection wells located in the center of the state, but I wanted to know more about the seismic activity specifically, so I went back to the data. Using the Oklahoma earthquakes dataset, I grouped the seismic events into each year and saved to a variable. Then I called that variable into a plot to display the information. And what I saw was a dramatic change. This visualization shows a consistent average of 24 seismic events per year for 36 years. Then, in 2015, the faults began to slip with the increased volume of wastewater and produced 4,576 seismic events in 2015. I then wanted to compare this graph to the seismic events in the Appalachian region. Using the Appalachian region dataset, I recreated the process. I created a variable, then called it to the plot, and the data produced a very similar graph to the Oklahoma region. The data shows an average of 18 events per year and spiking to 580 seismic events in 2013. I also looked at the magnitude of seismic events and the depth of those events for each region. But we are out of time today. If you would like to see more of my project, please feel free to reach out to me directly or view the project on my GitHub. Thank you everyone for joining today. Again, my name is Julie Gambill and I can be reached at the contact information below.